Hey everyone, welcome to Models and Agents, episode 104 on July 7th, 2026. Let's see what shipped. The AI world never sleeps. Here's what you need to know today. Real-time voice agents just got cheaper and more capable. OpenAI split its real-time API into specialized models with lower latency. OpenAI released 2 new models for voice agents today, while Tencent dropped a large open mixture of experts model, and NVIDIA added audio support to one of its Nemotron variants. Anthropic also shared new interpretability tools that run on open weight models. On the agent side, a new local coding harness appeared, and community experiments highlighted both quick training wins and quantization pitfalls. The top story today centers on OpenAI's updates to its real-time voice stack. OpenAI added GPT Realtime 2.1 and GPT Realtime 2.1 times Mini to its API for low-latency voice agents. The Mini variant functions as a reasoning model and carries the same pricing as the prior GPT Realtime Mini. Both models use improved caching that cuts P95 latency by at least 25%. The updates target agentic voice use cases and include WebRTC connection support. Developers can now run more responsive voice loops without moving to higher cost tiers. This release continues the ongoing work on reliable agent tool calling that we saw discussed last week. Watch for how the split models affect tool calling stability in production voice agents. Tencent released Hi3, an open 295 billion parameter mixture of experts model. The model activates 21 billion parameters per token and carries a 256,000 token context window. It is aimed at reasoning and agentic tasks and reports 78.0 on SWE-Bench Verified along with lower hallucination rates. Hi3 is released under Apache 2.0 and remains free to try on OpenRouter through July 21st. This moves the open weight performance conversation forward from the updates covered yesterday by showing another Chinese lab closing the gap on long context agent workloads. NVIDIA released Nemotron Labs-Audex-30B-A3B, a unified audio text model built on the 30 billion parameter MOE Nemotron Cascade 2 backbone. The model uses 3 billion active parameters, adds discrete audio tokens and an audio encoder, and keeps text reasoning and agentic performance intact. It supports thinking and instruct modes plus a 1 million token context window. Teams working on speech-to-speech or audio-augmented agents can pull the checkpoint from Hugging Face for direct comparison against the text-only version. Anthropic partnered with Neuronpedia to release an interactive demo of its interpretability methods on open weight models. The demo is available at neuronpedia.org/jlens and accompanies a paper on how Claude develops mechanisms for conscious access. Researchers can now inspect similar circuits in models they host themselves. Coder is a new Go-based coding and computer use harness released after 1,300 commits. It targets local Linux setups with llama.cpp and models such as QN 3.627BQ8. The tool supports skills, MCP, visual models, milestone planning, multi-chat orchestration, and an embedded file browser. A single binary runs offline or with any OpenAI-compatible endpoint. Users report strong results on reverse engineering and OpenSCAD loops. This adds another concrete option to the agent tooling layer we discussed in yesterday's episode. A 117 million parameter Cilia architecture model was trained from scratch on an H100 in 5 hours. Training used the Synth 100M dataset and the Muon optimizer. The model and code are available on Hugging Face and GitHub, along with an inference script that runs via UV. The model remains severely undertrained on only 82 million tokens, so further scaling experiments are expected from the community. Users report that Qwen 3.627b in NVFP4 and FP8 quantization on Blackwell hardware with VLLM 0.24.0 shows mid-task halting and repetitive failure loops in thinking mode. The BF16 version runs reliably, and the issues appear less frequent in FP8 than in NVFP4. Teams running agentic workloads should benchmark quantized checkpoints against BF16 before deploying. Try GPT Realtime Ride History 2.1 Mini through the OpenAI API for voice agent prototypes. The lower latency and new pricing make longer sessions practical. Pull Tencent's Hi3 from OpenRouter before July 21st and run it on SWE-Bench-style tasks to compare the 21 billion active parameters against Qwen 3.627. Test Coder on a local Linux machine with your preferred coding model. Its milestone planner and file browser integration are worth evaluating for offline agent loops. Run the Neuronpedia JSpace demo on an open weight model you already host to inspect attention patterns without needing Anthropic infrastructure. More quantized checkpoints for Qwen 3.627b are expected as Blackwell adoption grows. Additional OpenMOE releases from Chinese labs are likely following Hi3's Apache 2.0 move. Watch for VLLM updates addressing the NVFP4 agent loop instability reported this week. Okay, let's pop the hood on mixture of experts routing. Everyone talks about MoE as a simple activate fewer parameters, get free speed trick. In practice, the router must decide which experts to wake for every token, and that decision sits at the center of the efficiency story. A lightweight router network scores every expert and typically keeps the top K. The cost of that scoring grows linearly with total expert count, so labs add auxiliary load balancing losses during training to stop the router from always picking the same few experts. When the router is well tuned, inference only loads the active experts into memory, which is why a 295 billion MoE can run at roughly the speed of a 30 billion dense model. The hidden cost appears at training time. Every token still computes router logits across all experts. Poor routing can leave some experts undertrained, creating quality cliffs on out-of-domain data. The practical rule of thumb is to watch expert utilization histograms. If any expert sits below 1 to 2% activation, you are wasting parameters and should either increase the load balancing coefficient or reduce total experts. Teams choosing between dense and MoE should therefore measure both tokens per second at inference and the variance in expert activation during their target workload, rather than trusting headline parameter counts. Before we go, keep an eye on VLLM updates addressing the NVFP4 instability and the next round of OpenMOE releases expected after Hi3. That wraps up today's AI briefing. Share this with a developer or builder who wants to stay current. Subscribe wherever you listen. See you tomorrow, and if you'd rather watch than listen, find us on YouTube at Nera Network. Links in the show notes. And before you go, this show is part of the Nera Network, a family of daily podcasts on tech, science, and markets. Each one a short, sharp briefing you can finish on the commute. If today earned its place in your feed, here's your next listen. Tesla Shorts Time, your daily deep dive into everything Tesla. Find every show free at neranetwork.com. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.